All right, today we're diving into something that feels like it's straight out of science fiction. It's called Alpha Evolve, and it's pushing the boundaries of what AI can even do.
You know, we've gotten pretty used to AI that can do incredible things, right? You can summarize a book, write code, even create art. But all of that is based on the stuff we humans have already created. It's basically the world's most sophisticated remix artist. So that leads to a huge question. Can an AI actually have its own eureka moment? Can it discover something genuinely new?
Oh, get this. The answer seems to be yes. There's a new AI agent from Google DeepMind that's doing exactly that. It's not just learning from us anymore. It's actually coming up with brand new solutions to problems that have had the smartest people on the planet scratching their heads for decades.
And look, this is a whole new level. We're talking about going way beyond what even the most powerful LLMs can do today. See, coming up with a truly new algorithm is, well, it's incredibly hard. It takes a spark of creativity, some deep insight, and just tons of trial and error. That's the exact challenge Alpha Evolve was designed to take on.
So this really is a fundamental shift in how we think about AI. On one side, you've got your conventional AI, your LLMs. They're amazing at learning from and remixing everything we've ever written. But Alpha Evolve? It's playing a totally different game. It's all about pure discovery, finding new algorithms from scratch, algorithms that are often way more efficient than anything we humans have ever come up with.
Okay, so how in the world does it evolve code? The name kind of gives it away. The whole concept is borrowed from biology. Yep, natural selection. But instead of evolving species over millennia, it's evolving computer programs in, well, a fraction of the time.
The fancy term for this is an evolutionary coding agent. But really, you can just think of it as a system with two crucial parts. First, you've got the creative engine, in this case, an LLM like Gemini, that just throws out tons of ideas for code. And second, you have a super strict, super fast judge that automatically tests every single one of those ideas to see if it works, and more importantly, how well it works.
And this whole thing runs on a really cool self-improving loop. So, step 1. Gemini just generates a whole bunch of different programs, a whole population of potential solutions. Step 2, this automated evaluator comes in and tests and scores every single one. No mercy. Step 3, only the best, the fittest programs get to survive. And step 4, this is the key. Those survivors are then used as inspiration for the next generation of code. They get mutated and improved upon. This loop just keeps running over and over, and with each cycle, the code gets better, smarter, and more efficient.
Now, this isn't just some cool theory in a lab. No way. Alpha Evolve is already out there in the real world, working on some of the most complex computer systems on the planet. We're talking about Google's own massive infrastructure.
Check this out. For more than a year now, an algorithm discovered by Alpha Evolve has been running parts of Google's data centers. It found a smarter way to schedule tasks, and that one change freed up 0.7% of Google's entire global computing resources. Now, 0.7% might not sound like a lot, but at the scale of Google, that is an absolutely massive, ongoing win.
And here's where it gets kind of meta and really interesting. Alpha Evolve is literally making itself and its cousins better. It figured out how to speed up a crucial part of training the Gemini models by 23%. That small change adds up to a 1% drop in the total training time. Again, that is a huge saving in time and energy.
It's even diving deep into the kind of super low-level code that human experts have already spent years optimizing down to the last byte. You know, the stuff where you think there's just no more performance to squeeze out. Well, for one critical component used in tons of AI models, Alpha Evolve found a way to speed it up by over 32%. It's finding major gains in places we thought were totally tapped out.
Okay, so it's a rock star at engineering problems. That's clear. But what happens when you point this thing at pure science, at really fundamental challenges? I mean, optimizing a data center is one thing, but can it solve centuries-old math puzzles?
Well, let's take matrix multiplication. It's one of the absolute cornerstones of modern computing. And for one specific type of this math, the best algorithm anyone had ever found was discovered all the way back in 1969. Think about that. For over 50 years, nobody, no human, could find a better way to do it. And then, Alfa Evolve shows up and, yeah, it discovered a new, provably faster method. It just shattered a record that stood for half a century.
And it's not a one-off. When they set it loose on over 50 different open problems in math, about 3/4 of the time it managed to rediscover the best solution we humans already had, which is impressive on its own. But here's the kicker. In 20% of those cases, 1 out of 5, it actually found a better solution. It made real, tangible progress on unsolved math problems.
I mean, we're talking about it chipping away at puzzles that have been around for centuries. It actually made the first real progress in years on the famous kissing number problem, which is a super cool geometry puzzle about how many spheres you can pack around a central one. It's a classic, and Alfa Evolve just nudged the boundary of what we know. So, let's step back for a second. What does all this actually mean? It's obviously a ridiculously powerful new tool for scientists and engineers. But what are the bigger, long-term implications here?
Honestly, the potential is just staggering. You can imagine pointing this thing at almost anything, discovering new materials with incredible properties, designing life-saving drugs, coming up with new green technologies, optimizing, well, pretty much any complex system you can think of. The basic idea is, if you can clearly describe a problem and have a way to check if a solution is good, you can unleash Alfa Evolve on it.
Now, of course, with any massive breakthrough like this, it's really important to keep things in perspective. You've got folks in the broader research community, like Simon Frieder from Oxford, pointing out something crucial. He notes that without the full code being public, it's hard for other scientists to independently verify everything. And look, that's a totally normal and healthy part of science. This back and forth is how we make sure results are solid, especially with systems this powerful.
For their part, Google emphasizes that all of this work is guided by their core AI principles. These are the rules they've set for themselves, commitments to things like fairness, privacy, transparency, and most importantly, making sure this stuff is developed and used safely and responsibly.
And all of this leaves us with a really fascinating, kind of mind-blowing thought. For maybe the first time in history, we have a tool that doesn't just organize what we already know, it can actively discover brand new knowledge. The bottleneck is changing. It's not so much about how we find a solution anymore, it's about having the wisdom to pick the right problems to solve in the first place. So the question we have to ask ourselves isn't just can we solve it, it's what should we solve next?